Good morning. Welcome to episode number 15 of the ZOOMTOWN experiment. For today's episode, we're going to be taking a look at a way to mount up all of our sensors onto one bracket that will attach to the Zoomie and hold everything in place for us. It's a rather complex design, but after many test runs on it, I finally got something I think I'm happy with. This is the Zoomie as we know it right now. We've got our bottom deck that holds our caster wheel, our two motors, and our drive wheels. Up on the top side, there's a bracket here. Whoops, let's try that again. There's a bracket here that will hold one of our three power supplies, and this is our motor driver. And of course, leads from this will go all the way up to the top of the Zoomie where the brain box is, and the other connector here will connect wires down to the motors underneath. And I'm using 3mm standoffs here. I believe these are 400.47 inches, so I'm going to guess they're probably 12mm. We've already talked about the wheels, the O-rings, etc. Inside the wheel is the little magnet that the rotary encoder is going to need. Now, when we showed you this the last time in the real world, there was a plate that I just made up to hold the motors and the wheels and all that in place. So I really had to think about how to minimize number of components, bring all of my sensors into one location, and ideally they, for the most part, all needed to be mounted up near the front of the Zoomie. So this is the crazy contraption I came up with. As you can see, it's up at the front of the Zoomie. The caster wheel is always in the back, trailing. It holds all of our sensors. We've got our rotary encoder there and here, right outside of the wheels. It holds them at the correct distance, so I've got the proper gap between the magnet and the sensor. Underneath, you can see I've got my Hall effect sensor here and here, and then these are the two line following photoreflective sensors. And this is our sharp time of flight sensor. All of that fits on this one bracket. As you can imagine, this is one of those projects that a 3D printer is really, I won't say mandatory, but it certainly helps a lot. 3D CAD also helps a lot for all of the design work, and then the 3D printer to print up these crazy shapes and so forth. Now, in truth, yeah, you could make this up out of anything and glue together pieces of polystyrene or whatever material you wanted, even wood for that matter. But the 3D printer sure does simplify a lot of things. So I'm very grateful for both of those technologies, 3D CAD, in this case Fusion 360, and my 3D printer, which is over here. You often see it off my right shoulder, or at least bits and pieces of it. So they're definitely helping on our project. So this gives you an idea of what I tried to accomplish to get all the sensors up near the front, all mounted on a common bracket, all held in the proper location to where they need to be utilized. And it didn't turn out too bad. Underneath, you can see how I'm going to bolt it to the bottom deck to hold the motors in here and sandwich them in nice and tight. Now let's turn our attention back to the workbench, and I'm going to show you the real components here, and then we'll start kind of bringing all the different pieces and elements together. This is the sensor bracket. It's a rather complex thing. It's a different color, but it's the same exact thing that's in the 3D CAD program, Fusion 360. Here are our two rotary encoder sensors. They would fit into these wings here and here. and they'll probably be further secured with a piece of tape or perhaps a dollop of hot glue. Then we've got our two Hall effect sensors, which fit down here and here, and their leads will pass up through that square hole. The photoreflective sensors get pushed in from the top side down, and they'll sit flush on the bottom of the bracket. And finally, the time of flight sensor fits down into this little notch here, and it's actually held quite securely. I don't even know if I'll need anything additional for that. Now, part of the issue at this point, this can all get assembled easy peasy, but we've also got to manage all of the wires to get from here all the way up to the top of the Zoomie. At the top of the Zoomie is where the logic control board will be, or the brain, if you will. So dealing with all the wiring is always a huge project with any type of electromechanical device. You got to route the wires in a safe way. You want them secure. You need to be able to understand the wiring once it's in place. There's a whole lot that goes on to the thought process for working with a bunch of sensors like this. Now, my choice to go with, and it's really not my favorite, but for all-around practicality, it's what I've chosen. And it'll be your DuPont jumper wires like you use on breadboards and with other devices. And the thing I like about it, I'm going to pick clusters of wires based on their color. For example, say the Hall effect sensor, it needs a ground, it needs a hot, 3.3 volts, and then it needs a signal. And if both of them are wired the same way, I can trace out the color coding from the sensor bracket all the way up to the logic board on the top of the whole Zoomie. Now, the reason why I don't like these, they're very stiff, they're not very flexible because they're very stiff, and I don't often think they're of very good quality. These are often bought or made in China at a very economical price. I think each wire works out to about a penny a piece when you buy a quantity of these things. So it's very economical, but I do worry a little bit about the quality. Generally, I like to work with silicone insulated wires, and they're very, very flexible. This is my favorite, but it is also a whole lot more work if I've got to go through and put a crimp on the pins and fit them into the jacket or housing for the DuPont connectors. So as I go through this assembly, this will be a prototype one. I'm going to assign color codes, the correct color choices that I want for each sensor. They'll be duplicated on left and right side so that things make sense, and I can get that data off to the schematics, so when I build all 16 of these, I'll have something to follow there. Now, for the photoreflective sensor, the Hall effect sensor, and the time of flight sensor, those will be, I'll cut an end off and then just use the other end of the jumper wire. For the time of flight sensor, I'm sorry, that guy will be a little different because it has its own type of connector, and I only need 3 wires or 3 of these conductors because we're using it with analog output as opposed to with I2C. So I will have to put the jumpers or the DuPont connectors on the end of it. In this case, female pins and a 3-pin housing. Now, getting the wires from here, getting it all put together here is kind of easy. We'll assemble it all soldered up, and that ain't a big deal. The other thing that you may be questioning at this point, you know that this photoreflective sensor is going to need probably 2 resistors. The Hall effect sensor, I don't believe needs a resistor. The the time of flight sensor doesn't need a resistor or anything. The two rotary encoders may or may not need resistors. So how do you deal with all that? Well, essentially I'm dealing with all of that up on the logic board. I just need wires coming from here going up to the logic board on the top of the Zoomie. That's where I'll have the resistors for pulling up signals or limiting current to the LEDs, etc. Now, you can kind of start to get an idea how unruly all these wires could be to get from down here all the way up to the top of the Zoomie. You're right, it will be a problem, but what I've done, and I'm going to take you forward a couple of weeks on the design here, because the battery deck and all that is our next deck up. And I'll be those episodes will be coming up in a few weeks here. This is the battery deck, and then this is the power deck here. But you'll notice I've got these slots on the sides of all the decks. And up here at the front, there's room to squeeze up some more wires. So all these wires will get fed up through there all the way up to where the logic deck will be, or the very top deck, which would be right up here. This is where the actual logic PCB board would attach. So all the wires would come up above that and then connect in from the top. Of course, the header pins for our DuPont connectors. So that's the phase we're at with the design and getting into now more of the mechanical things. So from here, we're going to go through, I'll take you through the assembly of this. Most of it's pretty rudimentary. I'm not going to show you the soldering and all that fun stuff. I'll probably time-lapse it, throw some tunes on there for you to listen to until we get all the pieces together. If anything comes up along the way that needs commentary, I'll throw that in during the process. Working through it systematically, I'm just going to pick each type of sensor, cut the wires to the length that I think they should be, and either solder on the ends, crimp on the ends, whatever's needed for the particular application. And as you can see off on the left-hand side here, the schematic is over there where I'm noting wire colors, etc. And that'll just make life a lot easier should I get into a situation where I've got to diagnose problems after the whole vehicle or the whole Zoomie is assembled. So this is going to take a while, so sit back, relax. Hopefully you'll enjoy the little tune we got to play, and we'll fast forward this so it only takes up about 20 or 30 seconds. And as you can see, there's quite a lot of wires in this little tiny area. And that's kind of the importance of this bracket. There's a lot going on here, and it's going to take some time and energy to get it just right for all applications. Now, because we've got these magnetic encoders, we've got to get our little magnets inside each of the wheels. Doesn't matter which way they go in. The important thing is it's got to lay flat, and these things always want to go on edge like that because they are attracted to the axle. So it takes a few tries to get it, and then hopefully it'll stay there till we get the rest of the assembly. Like that. Now, of course, I'm going to have to take this all apart and wire on some, or solder on some wires on the back sides of these motors. But this was the original bracket that we used just for our mock-up in the previous video. Now, this whole contraption is going to go on here like so. Hopefully we won't knock everything loose. Slide that down, get the wires out of the way. And we should be able to get a couple of wires snugged up. Or I'm sorry, a couple of the screws snugged up so this whole assembly stays together for the time being. And now you'll get an idea of how all this will fit together. 2 Hall effect, 2 photoreflectives, 2 encoders, and a time of flight sensor. That all fits in there. I've really got to watch the gap between the wheel and the sensor. They should not touch, but they should be in close proximity. And then I want to show you one more thing with this assembly. We were talking earlier about routing the wires and trying to keep them wrangled in. And I had mentioned on the 3D drawing that we have these slots here that we can use to guide some of the wires. Now you're looking at the battery right now, and I'm just going to get these on here for the time being, but these would hold the wires in like so, and then they can come up through the top of the Zoomie. It's going to take a little bit of wrestling around to get all the wires up to where we need them, but that is the subject for another video coming up soon. So this will pretty well wrap up our sensor bracket, how they're going to be wired and connected up to the Zoomie on the logic board, and a little bit about their purposes. Now we're going to have a video here coming up next where I'll explain the function of each of the sensors and everything up to this point, kind of a recap video for next week. After that, we're going to move on to our power supply stuff. Shortly after that, it's going to get close to the time where we start getting this thing to move around ZOOMTOWN. Well, thanks for watching. I look forward to seeing you in the next episode.